Good morning, students. In the last class, we have discussed few concepts of carbon and its compounds in detail. Now, we shall move on to the next part of the lesson where we are going to discuss about certain concepts like alkenes, alkynes and homologous series. Now, let's welcome once again for this session of carbon and its compounds class. So in the last class, we have discussed about alkenes in detail. As I told, alkenes is also one category of the organic compounds in which we can see the single bond between the two carbon atoms. Now, the next class of the organic compounds is referred as what we call alkenes, which comes under the category of aliphatic hydrocarbons. Alkenes, as I told, they are come under the category of saturated hydrocarbons, whereas alkenes are considered as what we call unsaturated hydrocarbons. So what's the difference between saturated and unsaturated? In case of saturated, the meaning of that word is the bond are completely satisfied, or in other words, in between the carbon atoms we can see what we call single bond. The single bonded carbon arrangement is come under the category of saturated hydrocarbons, whereas double bond as well as triple bond are present between the carbon atoms. So wherever there is a double bond or triple bond between the carbon atoms, we call those hydrocarbons as what we call unsaturated hydrocarbons. Now this class of hydrocarbons also have their own special features. So as alkanes, I told, the compounds that belong to the alkanes are end with what we call ane. In a similar manner, the names of the alkenes are also end with what we call ene. But whenever the word is end with ene, the compound name, we call that particular group of compounds as what we call alkenes. But the one major difference what we have to notify here is, in case of alkenes, the first member is methane, whereas in alkenes, the first member is what we call ethene. So it starts with second carbon atom. So there is no compound in the nature which exists as methane. So the first member of alkene is ethene, but the number of carbon atom is 2. And as I told, whenever the meth, eth, prop, these prefix are used, the number of carbon atoms remains the same. No change in that one. Only the suffix part is going to be changed. Here also the suffix part is end with ene. So the first member of this particular class is ethene and it starts with second carbon atom. In a similar way, the second member of this particular class is propene, next is butane, so on. Now, as I told, it is unsaturated hydrocarbons. It is not stable, they are unstable. So in order to make it stable, we can convert these alkene compounds into alkanes by a process called hydrogenation by passing what we call hydrogen gas. So when you pass the hydrogen gas, whatever the alkene are, say for example there is a ethene. Ethene can be converted to ethane, or propene can be converted into propane. This can be done by a process called hydrogenation. So this is best example we can quote for this. Hydrogenation process can be done in the conversion of oil and fats. So that's the best example. So how the oils are going to be prepared? The fats are get converted into oils by means of what we call hydrogenation process, which means the fats are saturated hydrocarbons, whereas oils are referred as what we call unsaturated hydrocarbons. Now let us look into the compounds of alkenes. So as the alkanes have general formula, alkenes also have a general formula which states CnH2n. Remember students, the general formula of alkenes is CnH2n. Similarly, N stands for number of carbon atoms. Let us look into here. Yes, if N is equal to 1, the molecular formula becomes, sorry, there is no 1. If N is equal to 2, it becomes C2H4. If N is equal to 3, because it starts with number of carbon atoms 2, so that's why we have to substitute N as 2. If N is equal to 2, the molecular formula becomes C2H4. The name of the compound is ethene. Similarly, the second member of the class is propene, so we have to use a number of carbon atom as 3. So if N is equal to 3, it becomes C3H6. The name of the compound is propene. Similarly, N is equal to 4, the formula is C4H8 and becomes butene. If N is equal to 5, it becomes pentene, the formula is C5H10, N is equal to 6, the compound name is hexene and the formula is C6H12. If N is equal to 7, the name of the compound is heptene and the formula is C7H14. If N is equal to 8, the name of the compound is octene and the formula is C8H16. If N is equal to 9, the formula becomes C9H18 and the compound name is nonene. And if N is equal to 10, the compound name is decene and the formula is C10H20. So totally the number of compounds belong to this particular class is 9 and starts with ethene and number of carbon atom is 2. So let us look into the structure of this alkene compounds now. Similarly, when you write for alkenes, in the same manner you are going to write the linear chain of carbon atoms here. But one thing what you have to observe here is, to any one of the pair of carbon atom, we have to show what we call double bond. So that indicates the compounds are alkenes. The major feature of the alkene is it should have double bond. If you write all single bond, it becomes alkanes. So one pair of carbon atom, at least one pair, not all the carbon atoms. So one pair of carbon atoms should join with double bond or should pair with double bond. The remaining carbon atoms what you are going to attach should have single bond along with hydrogen atom. So you can see the compounds here which are going to be written as alkene compounds: ethene, propene, butene, pentene. So all these compounds, like that you can write for all the remaining compounds. So where I have shown that the first is, as you have two carbon atoms, so you have to show double bond, and whenever the double bond has been written, check with the carbon atom that it should be satisfied with the 4 bond. It should not be exceed that one, children. Okay, so whenever you write the 2 bonds in between the carbon atom, it should be always check that the carbon atom which is going to be attached to the other carbon atom should satisfy with what we call the 4 bonds. Now next, move on to the next class of the organic compounds is alkynes. Similarly, alkynes are also unsaturated hydrocarbons, no doubt, and they have triple bonds between the carbon atoms. Here also the names of the compounds which comes to this category are end with YNE. So the compounds, the names which are end with YNE, they come under alkynes. Those which end with ENE, which comes under the category of alkenes, and those which come under the compounds ANE are come under the category of alkanes. This is what we have to know, the difference between the alkenes, alkenes and alkynes while using or while informing about the names of the compounds. Here also the same manner as you have studied in alkenes. In alkynes also the first member is nothing but ethyne. It's also referred as acetylene or ethylene. You can also call by other names for this compound: ethyne, acetylene, ethylene, they are all same. So here also the first member is ethyne and starts with number of carbon atoms 2. Again, there is no compound in the nature which starts with methane. So similarly, the second member is propyne and third member is butane, like that it goes on. Here also alkanes are much more unstable, so you have to convert them into alkanes. Before that, the alkynes should convert it into alkenes, then it should be converted into alkanes by a process called hydrogenation, again by passing the hydrogen gas in the presence of what we see the catalyst, and the normal we use the catalyst in this particular process is nickel. So nickel is used as a catalyst, and in the presence of hydrogen gas we are going to convert these alkynes to what actually alkanes. So alkenes and alkynes are unsaturated because they are unstable organic compounds. So you have to make them into stable. So that's why we have to go for a process called hydrogenation, which is also referred as addition reaction, through which we can able to convert these compounds into a stable compounds, which are called as saturated compounds. Now let us look into the structures of alkynes compounds now. As you have seen for alkanes and alkynes, alkynes are also having a general formula, that is CnH2n minus 2. So remember students, the formula for alkynes is CnH2n minus 2. So now it is clear now, alkanes is CnH2n plus 2, alkene CnH2n, and alkynes CnH2n minus 2. Again the same thing. You are going to see the structure here, how to write for the alkynes again. As you written for alkenes, in the same manner you have to write for alkynes. Similarly, go start with ethyne, which having the carbon atoms 2. substitute N is equal to 2, it becomes what actually? C2H2. The formula becomes C2H2. You can see the structure here. So here also one pair of carbon atoms, while writing the linear chain of carbon atoms, between that any pair of the carbon atom we have to show what we call triple bond. That is very important. The remaining carbon atoms should attach with single bond. So here also you have to be careful that whenever you write a triple bond between a pair of carbon atoms, and that carbon atom should be satisfied with only 4 bonds. You have to write only one single bond and attach with the hydrogen atom. So you have to carefully while writing the structures, carefully you have to observe that the carbon should satisfied with only 4 covalent bonds. However, you want to write the structures, it should be, notice that it should always be 4 bonds, and here one pair of carbon atom should attached with what we call triple bond. So propyne, again we have 3 carbon atoms, butane 4 carbon atoms, pentane 5 carbon atoms, like that you can write, and you have to mention show the 3 triple bonds you are going to write in between the carbon atoms. So this is about the structures of alkyne compounds once again: ethyne, propyne and pentane. Now next category of the hydrocarbons is closed chain hydrocarbons. So far we have discussed about aliphatic hydrocarbons, which are also referred as what we call open chain hydrocarbons. Now we shall move on to what we call closed chain hydrocarbons. So closed chain, as we know, here the carbon atoms are actually arranged in the form of cyclic ring. So whenever it is written in cyclic ring or a closed which results in what we call a closed chain or a ring structure, what we can say. Under this closed chain hydrocarbons, there are 3 different categories are there. Number 1, it is called as alicyclic hydrocarbons or alicyclic compounds. What are these alicyclic compounds? Alicyclic compounds are those compounds which contain a ring of 3 or more carbon atoms. So it starts with number of carbon atoms 3. And normally whenever you write the compounds of alicyclic, we use the prefix as what we call cyclo. So cyclo, if it starts with 3, so what is the name of the carbon compound if it starts with 3? Yes, it is prop. So what we have to use the name for this? Cyclopropane, because cyclopropane, propane again it is an alkane compound. So alicyclic. So alicyclic, in the word there is a meaning called cyclic, means closed chain of course. Ali means aliphatic. So which is aliphatic? Open chain hydrocarbons. In that open chain hydrocarbons, which category, which class has this particular structure? That is alkanes. So alkanes can be written in the form of cyclic manner. That's why it is called as alicyclic hydrocarbons. And it starts with, so whenever there is it starts with the 3 carbon compounds. So whenever there is a 3 carbon compounds, we can write those 3 carbon compounds in the form of a cyclic ring, and that results in a triangle shape. So cyclopropane. Similarly, if you write for 4, it becomes cyclopropane. If it is 4 carbon atoms, it is cyclobutane. If it is 5, cyclopentane. So whenever you say the cyclopropane, cyclopentane, cyclohexane, like that, we have to write the carbon atoms in the ring structure and attach with what we call the hydrogen atoms with single bond. But the nature of the hydrocarbon is unsaturated hydrocarbons. They are all unstable hydrocarbons. You can see here the structure of closed chain here. As I given the example, cyclohexane, cyclopentane, you can write. Even sometimes we can also see one or more double bonds can also be seen between the carbon atoms. This is cyclopentane what I have given. Even for alkenes also we can able to write this in the closed structure. Not only for alkenes, even for alkenes also we can write the structure in the form of closed chain. That's why I have given an example of cyclopentane, where you can see the double bond is also present. And cyclohexane, where I shown 6 carbon atoms will be written in the hexagonal shape, and for that you are going to attach the hydrogen atoms. Next category, what you are going to see here, the image of the structures are none other than aromatic compounds. So aromatic compounds, as the name indicate, aroma refers to smell. So aromatic hydrocarbons are also a group of cyclic compounds where the carbon atoms are arranged in hexagonal shape. In most of the aromatic compounds, the carbon atoms are arranged in hexagonal shape. where we can see the alternate double bonds between the carbon atom. Single and double, like that alternative bonds can be able to see in this group of compounds. Example we can give for this is benzene, toluene. Like this we can give example naphthalene. So all these are some of the examples for this aromatic compounds, where we can see the carbon atoms are arranged in hexagonal shape, which having alternative single and double bond. Next category is heterocyclic compounds. We have another category of closed chain compounds. Here also closed chain compounds where the other than hydrogen, it can also have one or more atoms of either nitrogen or oxygen or sulfur, etc. as its constituents. So in these compounds other than hydrogen, as we know carbon has more affinity to combine with hydrogen, no doubt, but other than hydrogen, carbon can also combine with other atoms like nitrogen, oxygen or sulfur. If such atoms are going to be arranged in the chain or in the ring formation, then you call that particular group of compounds as what we call heterocyclic compounds. So hetero refers to different. If other than hydrogen, if any other atoms are present, then we call them as what we call heteroatoms, and that group of compounds are referred as what we call heterocyclic compounds. Now you can see the structure which are having under the category of heterocyclic compounds, like 1,3-diazole, 1,4-oxazine, 1,2,4-oxathiazine, 2-methyl, 1,3-oxazole. These are all some of the structures of heterocyclic compounds which are given the skeletal form of the carbon attachment. Now next category is homologous series. The next concept in this particular lesson is homologous series. Now so far we have seen alkanes, alkenes and alkynes. What actually you have observed in those compounds name or compounds? When you write the formulas of alkanes or alkenes and alkynes, what you have observed actually? Can anybody guess? Yes, what you have observed is that you have seen the difference of carbon and hydrogen atoms from any of the class of the organic compounds. Say for example ethane, ethene, ethine, propane, propene, propyne. Like that, if you just look into these compounds formula, what you are going to observe is that there is a difference of carbon and hydrogen unit, which means there will be decrease in the number of hydrogen atoms in each class of the compound. The same compound has been seen in 3 different classes. Say for example ethane has got some formula, ethene has got some formula, ethine has got some formula. Even though they have the same number of carbon atoms, but there is a difference of what we call hydrogen atoms. So such class of compounds where we can see the difference of CH2 are referred as what we call homologous series. So what are homologous series now? Homologous series are those group of organic compounds where we can see the difference of carbon and hydrogen atoms. Say for example, any organic compounds of a particular class can be regarded as homologous series, as I have taken for alkanes, alkenes, alkynes. Similarly, we can go for some other organic compounds which are having different groups. So normally whenever you write any organic compound belonging to the same category, you are going to see the difference of what we call carbon and hydrogen. So wherever you come across the difference of carbon and difference in the sense, you are going to see the decrease in the number of hydrogen atoms from the previous class to the next class. Next category is what we call IsoMedicine. We have another group of carbon compounds property. As we have discussed in the beginning, I have told catenation is one property, tetravalency is another property. In the same manner, we have one more important property of the carbon compound is referred as isomerism. What is the meaning of this isomerism? Isomerism means we have certain organic compounds where we can see the formula remains the same, the molecular formula remains the same, but structural formula differs in sense they have different arrangement of carbon atoms. So carbon atoms can be seen in different arrangement. It may be branched, it may be some way, it may be closed chain, whatever it is. But arrangement of carbon atoms may differ, but those compounds will have same molecular formula. Such compounds are referred as what we call isomers, and the phenomena is known as what we call isomerism. So once again, isomerism is nothing but the process where the compounds having the same molecular formula but differ in structural formula. You can see here the structure. What I am going to show here is the structure of pentane. You can look into the structures of pentane. So pentane can be written in three different ways. One is the normal structure, what I am going to show, that is the linear chain. Another two form can be written as a branched chain of the carbon atoms. You can see the arrangement of carbon atoms here. One is having a 4 carbon atoms where we can see the arrangement of different ways. Okay, another structure also you can see the one carbon atom has been branched. So and also at the same time the number is also going to be changed. If you write the normal structure, there is a normal chain, it is called as N-pentane. Other two forms of the pentane are neopentane as well as isopentane. So totally the pentane will have three different structures to write, have three different forms of pentane. We call them as what we call isomers. So isomers are nothing but the structures having the same formula but they have different structural formula. So the molecular formula for this compound is, that is pentane, so it is an alkane compound, C5H12. That's a formula for all the three forms, no difference at all, but only the thing is that structures are different. You can see the arrangement of carbon atoms in different ways. The formula is C5H12 but structure is different. So this is an example what we can give for isomers. Like that we can write for butane also. Butane is another isomer, like hexane. So many compounds you can able to write in different structures having the same molecular formula. So with this we have completed the chapter carbon and its compounds in detail. So we'll meet in the next session with a new topic. Till then, take care. Thank you.